Okay, cool. Um, hello, hello. Looks like we're streaming. I got something. Let's check out chat. So, okay, that one worked. Hear myself. Good there. Okay, cool. Everything's up and running. So today we're going to go over the Quartus, not Quartus, we're going to go over the Analogue Pocket OpenFPGA Buildflow using Google Colab. We're going to demonstrate this with the interactive demo that is on the Analogue GitHub page. And once we do it, we'll kind of like do a code we'll review the code, review the different modules, and talk about what's happening on the system. Okay, let's just dig down into it. I'll post this Google Colab page so that you're able to install Quartus, get things working, doing stuff. I'll put this onto a GitHub page and post the link, at least on the Discord channel, and maybe some other places. I'll have to think about. I guess I'll add it to the description on the YouTube video. I'm not sure if I want to wait till we get something more substantial. Okay, so right now it's building the design, and this is located on the OpenFPGA, and this interaction one, I don't have it on the device right now, otherwise I would show you, but it's just a basic square with some cool video generation in the background. And hopefully it finishes soon so that we can talk about it. So the core top is the top level Verilog file for the OpenFPGA device. And we have two clocks. I believe one clock is what the bus is working off, and the other clock is the user clock to then to use as your own clock. We have the cartridge wires, or the cartridge. I mean, like the cartridge banks. Power off, reset. So it's all cartridge. These are off the port. If you have the hub, you have the hub for the OpenFPGA device. Here's some cellular RAMs. I need to go. I want to work on these sometime and see what speed we can actually run these things at. The SD RAM and the SRAM. The video signals, the debug USB, IO pads. Okay, these are nothing too crazy. Now here's the bridge. So this is using 74A. This is how the. So you pull up a block diagram. So this is how the bridge. If you look in this image real quick, why is that? Why would you do something? Okay, the bridge, the I/O bridge is coming from the Aristotle FPGA, which is Cyclone 10, and it's sending information over into your design on the Cyclone 5 FPGA. And the APF, this framework is provided for you, so we might look at that and see how that works. Okay, this is finished. I want to make sure it works. FPGA, output files. Save, yes, I'll overwrite it. Okay, I'm going better. What else is better? Okay. So now we're going to go into the files for this. So this is a new one. Copy it. I'm going to go to the cores. Oh, I'm supposed to I need to up the resolution. I'll do that in a second. And we're going to delete that one. Paste. I want to make sure I have the right Indianness because I was having an issue earlier. Going to eject it. Okay, looks like we're good to eject. B. Okay, cool. So this was built using Google Colab. Look at the pretty picture while we move forward. Okay, let's get the background resolution, something so so everyone can see a little bit better. There we go. Okay, so we built it. Kind of all over the place. Sorry for being all over the place. Let's talk about this script real quick. Then we'll talk about the top level. We'll edit the top level. We'll rebuild it, and then we'll maybe look at some other interfaces on the system. Okay, so first, this script it grabs the download for Cordis Lite, and it installs it. We have a beautiful install script that goes through the licensing agreement and installs the right device. If you do run this, make sure you're agreeing to their licensing agreement. Once this has been properly maybe try to run it or something weird. Oh, I think I just said yes to that. That was the same. Then we add the binaries for the Cordis to the path. So we add that. Then we're going to clone this interact demo. And any information, they don't really have any information on how to build it. And then we're going to go to the source FPGA directory. And this is going to use the various files in here. So this is going to use the QPF and the QSF file to generate the Cordis project. So we're going to use Cordis map. We're going to read the settings file. We're not going to write, and we're just going to do the AP core files with targeting the top level AP core. I think. I'm not exactly on these settings, so we're going to map it, which I assume is synthesis and technology mapping. Bits. I think this is basically placed in route. I don't know Cordis's terminology well enough, but we just call the fit command. The assembly command looks like it's just assembling the bit file. So taking the place and route design and assembling the bit file. And then finally, this looks like a post bit file timing analysis. Looks a little weird to do that post the design. Yeah, this isn't generating the bit file, so I'm not sure exactly why this is run afterwards. Seems like you should do that earlier, but okay. And then we go into this is the raw binary format. RBF is raw binary format. Then we're just going to use a simple Python script to do a bit inverted, doing a bit inverted byte on the raw binary format to kind of reverse all the bytes. And then we're able to get that working on the Analogue Pocket. So now let's go and change it and rerun it. So our goal here, so the inputs are kind of basic. You have memory, you have video, you have the controls. These they're defaulting a lot of the time. So what are some important things here? These are 3-stage synchronizers. I'm going from one clock period to another clock period. I don't think you could probably get away with just 2 flip-flops. You don't necessarily need 3 flip-flops, so that's a little bit robust, but in this situation, it really doesn't matter. It does not using that much utilization of the device. If you're going crazy on a lot of synchronizers, you can probably just go down to 2 and not 3. Okay, so this is an interesting case statement. So this case statement is looking at is snooping it's looking at the bridge address, and if the bridge address is ever something that needs to be read, these are just different variables that we can read over the interact.json interaction menu. Let me show you on this thing real quick. Looking at my little device, if we go to core settings, because can we zoom in a little better? There we go. We go to core settings and we go to like this increment frame value right here. Oh, you can see a lot better on that. That is frame count right here. Okay, that would be the frame count. And the square positions. Okay, that's pretty good. And those are the bridge commands that I'm not sure how much we're actually taking care of here. These are all for the bridge. Well, we might look more into the bridge. This is the bridge command controller. So it's taking all these bridge commands that are in this address space and doing whatever it needs to do with it at a system level. I might have to look at that a little bit more. I don't understand as much as I would like. So, okay, now here we're on the A clock still, so we haven't really gone to the B clock. I feel like everything's on the A clock, right? Anything on the B clock? It's probably the RGB clock. I'll have to look at that. Oh, so now this is reading the values. This is where you can change it. That's interesting. That has like a little knot there. Where that comes into place. Okay, so that's just replacing that. Oh, is it just looking at an edge when that switches to change it? Okay. So we should see. Oh, that's the PLL. The problem is probably making the RGB clock. So we have a bunch of information for the kind of the video generation. We have our parameters for a very simple, they're pretty small. We should see if we can increase the size. That might be something we can do relatively easily. X and Y counters for the pixels, generating the sync, HSync, VSync. Okay, here's where we're actually doing the drawing. We have the background color. We have some enables. We're going to change those to mask real quick. Now where is this XY for the square? Okay, there has to be another place where that square value is handled. That's the reset frame increment. Okay, so they're just looking at edge detection and then they're just updating the and then the next cycle. Where is that value coming into play though? Okay, where is this square position? Oh, right here. It's just okay. And then we have the okay, this is an audio. Yeah, that was the silence generator for the audio, which is important. And that's still off the A clock. And we're getting and that clock must be the RGB clock right here. Okay. So we're doing a 12 megahertz H pixel clock, which gives us our video of 320 by 240 at 60 hertz. So we should probably look at doing a maybe a different resolution. That might be something fun to do. We might do that today or tomorrow, depending upon how much time we have. Um, okay, so let's go ahead and make a mask signal for the colors. I want to change that up a little bit. For the reading portion, which is right here. Um, let's go look at the JSON real quick. So if we go here and we look at distribution, platforms, what am I looking for? No, it's at the top low right here. The interact JSON is what I want to mess with. I want to do some scalars. So they're doing that address to C. Okay, so the video enables. We want to change that to do some different cases. I think we'll just do FA0 for now. Or, yeah. And they have it up here as well. Okay. Let me copy this into a notepad so we can edit it. All this okay, so we want to do is we want to do an FA0 and we want to do video red mask. Okay. We need to create the video red mask signal. We're going to do that. All the way down there. Interesting that they reference it up here and they describe it down there. Okay. How many bits? I think we just want an 8-bit one, right? 8 bits would probably be the best. A 0. And then we need a synthesis. Where's those synchronizers? Right here. So let's do that. 7. And we'll do, okay. We're gonna be 7. Okay, and then this one. Need to look up make sure I get the Verilog bitwise OR. I mean, we're just doing that, right? The bitwise OR. Okay, so we're gonna remove these guys. Well, I think we can just put it here, right? I think that's all we need. Okay. So we're gonna go back here. Going to open the OR file, our little menu over here, and we're saving it. Let's do a quick diff code. I want to go here. I want to do a diff of or change that to that. Good. Added a red mask. Change that to that. Red. Add a red mask there. Change that line and got rid of those. Okay, so that should work. Then we can work on the JSON. So let's go ahead and rebuild it. Oh no, this one's not gonna, right? We want to do it. Okay. And then we want to edit the JSON file. So go ahead and get the JSON file and edit it so it's a slider. So we can put a slider on the mask. So what we want to do is we want to do a red mask. I take a slider. Yep. Default value is going to be 255. Max is 55. Increment. Oh no. This guy. Change. We'll keep those, but we're not going to be using it. Why does blue have a mask and the other ones don't? Interesting. We should be able to take this one and change it inside the system so we can change mask. Hmm. Okay, anyone have any fun questions about OpenFPGA? But I should probably type question discussion questions to help me. This works, it'll be pretty easy, and then we'll have to make a small little video. Okay. Okay. Looks like we finished. I have like a little time. Okay. So we're gonna change out the bit file and the JSON file. See what that does. Copy course. Yeah, this one, so it's the normal one. Then we have to go to the interact JSON to that one. Red. Okay, close it. And let's eject. Okay. Press B. Let's go. Did we break the bus somehow? Did everything work as expected? Now this is gonna be the fun part, debugging what we did. Let's make sure. Oh, is it trying to read the C and it's not there? I wonder if that's an issue. Um, no, it should have a default in that situation, right? I mean, I guess we try to do it one by one. Okay, so let's bring back those statements. See if that fixes it. Curious if that changes anything. We got rid of that case statement. I'm curious if it interesting or bizarre. Okay, do we have an end on this one up here? So it still exists now, and it's there, and it's being used. That shouldn't accept the break the bus thing. Okay, let's see if that causes it. Interesting. Okay. Now we might have to watch it. Not really interested. Let's see. Synchronizer. Okay, all the way down. Let's try running this again. Okay. While we're doing this, I want to explore the other one. Guy. Where's this guy? Okay. Core settings. We have a red mask now. Doesn't change. Okay, so that wasn't an issue. See if we can follow along. 182 warnings. Let's see if we can figure out the warnings. Anything come up with what I did? Only thing I would deal with the bus would be I wonder if the right data? I feel like those case statements wouldn't have mattered, right? You have to do a git restart and rebuild and see if it works. Okay. Try again. Curious if this one. I feel like we guaranteed it the first one worked. See? Pocket. Of course. Name this one. Could just be that we're renaming this one. Yes. Yeah, I mean, we eject this. Hopefully it works now. That's okay. There's something we did. Okay, so what we're gonna do now is we're just gonna show you rebuild it. Git reset. Check out. Okay, now it is clean. And we're going to rebuild. Maybe something in the build process. And something like that. We're doing something weird. Not give it a value that I was unhappy with. Okay, that's what I thought. So what could it be then? We got the video mask. Right about that. That matches. There's something wrong with that address? I think so. special in here I had to do. Default read data equals 0. Yeah, that should be fine. Okay. Let's try this one more time. Do I need to change the Indianness? We could try that. Thought this was the correct method. I didn't like that. Can try B2 and do maybe there's something I need to clean the project with. Okay, so I guess we're going to have to do a runtime, disconnect and delete runtime, and runtime run all. See what happens. That's weird. Okay, so downloads, we're gonna do that one. This one's, that's not the one. Okay, let's try the other one. Yeah, that's the one I tested. Yeah, that one works. Why does that one? Is it because there's already a hmm, okay. Well, let's try it. Do I have the Quartus set up here? Let's try it Quartus locally. We want to do the interact one. Okay, so we want to assemble it. Just gonna start how the design. We try it on the Colab and we'll try it locally. Anything different? Hmm. That being said, we have to get the let's go ahead and track main source FPGA files. Need to make sure that one's um okay, so here we want to open PowerShell here, turn on Jupyter Notebook. What we're doing. You're still working. Um, we have big here. We can try it out, and we can try out little as well. This Quartus finishes, we can build. I feel like it should be faster. forward it. So yeah, let's go here. Do a one below here. Call it big. Oh, seconds ago. So you just finished, did you? Yeah, you did. Um, go, go. So take the big one first. So let's try that. Um, um, so we're going to do the big one. Let's stream. And see if that works. Okay, so the big one clearly works. So we're going to have to big. So let's go here and copy and paste our right. So let's take this, go here, paste it, save it, and recompile the design. Okay, so oh, we had errors, compilation errors. That's important. Um, so we are missing a not there. Any place that wrote it. Okay. Okay. So where okay. 481. Okay, so it's 481. Oh, that. Sure. Seven. Any other errors or warnings? Nothing useful. Oh, doing the wrong. Um, I want to view the file. Okay. Files. Wow. Wow. Did it fix this? Oh, hey, I am building I'm trying to do a red mask for the Analog Pocket and doing a FPGA design and trying to debug it all. So you finished, but let's do. So we are trying to figure out if this work. Or yeah. Okay, quit this out. Um, and then we're simply just gonna rebuild it. There's something that this isn't working as I expected. They're all the same, slightly different sizes. There's some issue. Okay, download this one. I wonder. Okay, um, that's not what. HXB. Tell me if we are not seeing. Maybe our version is close. The UN, right? UN didn't all that. You do not. You start with it. Hey, you're missing a whole section. Not good. Let's open. Must be something to do way. Open FPGA. Go to course. Okay. Oh, they're different. They should be that size. Why are they different sizes? So big ends like that. Maybe we didn't get the right one. Okay. So yeah, Cyclone 5. We're using the OpenFPGA kind of developer kit for it. Um, we're having an issue because we have to reverse the binaries on the bit file. Being weird. No, it's still doing that same thing. Does it accidentally? I mean, we want to. You don't have an RBF file yet. You should. Yeah, so we should do 28C0. D2B80. D28C0. It must be this escape character. Um, we're breaking too early. Um, 0 plus plus 1. D28C9. 8. Okay. Now, all right. So it's saying you write to both of them. Okay, let me see. There's some weird thing where this is. T2701, but we need T2780, T1FFF0. Okay, let's see. Does that one? 270. Yeah, I'm not sure why. Okay, so we're gonna download this. Oh, it's 6. And just like right click, say open. Um, Downloads. T1FF0. But why? It says. Oh, do we not flush? Is this what you want from me? Do we not do proper file? My fault for not doing proper file management with Python? Probably is. Probably is. Okay, let's see. Now, if we do proper file management, we actually get consistent. Okay, look at that. Interesting that doesn't follow the example and go to. Okay, so okay, we got the red mask working, I think. So let's go ahead and try it. Be this guy. And I want to get this working so we can show it. And we're going to eject this. B and C. Okay, cool. Now, let me see if we go to core settings. Okay, so red mask. FA000. That's not what we did for FA000. Default value. We're definitely reading it back because we're getting that value back. Oh, why is that not coming through? Sampled it, right? Okay, so those settings no longer exist. Not red. Did we get a different color? Let me kind of interact before there. Okay, I guess that's true. That is red. Why did my mask not work? Oh, did we not do the parentheses? Then it ORed it. Okay, we're just not getting the cool red squares. Okay, I know how to fix that. We're just going to put priorities right here. There we go. And let's rebuild it. And we'll see if that works. Also, it's kind of weird that it started at 0. There's something that JSON that made it start at 0. Make sure I'm thinking the correct thing for this. Programming 255. Yeah, that's what I wanted. It read 255 on boot up, and it didn't. Okay. Mm, okay. So, what do you think? Right, data. Okay, so if Then for the JSON RGB, we write a 7, 4, 2. Oh, so they grouped them. Did enable this. Wait a minute. If I quit out, confirm. Play cartridge. No, not that one. Ow. Play cartridge. Confirm. Open FPGA. It starts there. Let's write that value. Because I don't think they have the default position. XY. Where there is. Okay, so there's the init X. Init Y. Maybe they didn't do a proper reset. But it should still be all ones. Yeah, I'm confused why that didn't get initialized properly. This should have initialized that value correctly. But I did not set in the core settings for 1. Maybe it's saving the settings. You're saving the settings somewhere. Okay. Okay. I see what you're doing. You're saving the settings. I think it's the persist. The persist is persisting between builds. Then it must save the persist somewhere. Okay, go back here. And we're gonna try that other design. Yeah. So one issue is we were not flushing and closing the file, which is critical. Always flush and close the file. Um, and another issue was order of operations. Very simple. Okay, now object. Okay, cool. So there's no red there for settings. Hey, why is it not working? Took away the red, which is what I expected. The red ain't coming back. I want to see the value go up. Like we should have a clear red value. This is probably the easiest way to see it. Okay. I wonder why the red mask isn't going through. Weird. Should work. The red mask should work. Synchronizing. Oh, this domain to this domain with that. It's all fine. Oh, I'm sorry, my bad. It's supposed to be 8. Just doing a single bit. Ah, okay, cool. But let's go ahead and do that. Okay, okay, that should work. Sorry, it's the whole synchronizer was a little bit different than I forgot to make it. So it was just doing 1 bit, and that's was useless, absolutely, utterly useless. Okay, so we have a whiff there. Okay. Um, Pretty colors. I need to find that other source of. We should look for that video. Let me see if I can go find the video I want to show up. Oh, AMD announced Xilinx stuff. Okay, we're gonna take a break actually. Let's go. Let me go find the video for that. Over here. I'll look at the YouTube. The AMD, right? The AMD DS. Okay. You can't hear this, but let me see if I can find this link, then we can talk about it. Where is it? Where's the Xilinx? Have anything where they talk specifically about the Xilinx? I'll have to go through this and actually find the link where the. Okay. They talked about AMD Xilinx stuff there. Um, Yeah, but I was gonna look for that cool video. I like too much. Someone had a really cool demo on FPGA. I want to go through that video right here. So, another world on a chip. Okay, cool. This video right here. I'll get this video working on the we can probably get this working easily, hopefully. I have to find the source code. I think we have the code in here. So he has code for this, so we should try this. We'll try that. Okay, that it finished. Okay, cool. Let's get this working and then we'll be done for the day. There's like a way. I wish there was a way you could just reinitialize the SD card feature. Okay, so we want to do cores, correct. Bring this over, and then we can be able to filter out the red. Like way too long. Um, that's okay. Now we should be able to eject this. Okay, we got the red in the background. Now, if we go to core settings, I should be able to do no red. And then we should be able to do something in the middle. Do something, yeah, let's do 32, 32. Do 32, do 64, do 63. You kind of see the red in the background. So let's do 127. That should be right below. You can see 128 right here. That's the big squares, so you get the nice big squares. Now, of course, I need to do 127, bunch of tiny squares. Okay, so we can do it. Now we just gotta do the color space conversions. So I guess we'll talk about color space conversions tomorrow. Now that we fixed this up, and I will work on the script to get this all working. I need to find a good way to people to follow along. I think this is a good way to follow along. It's just a little bit more difficult. Source files when I okay, I'll think of some ideas. Well, thanks for watching this, me try to debug the various issues with Python and the Verilog. But we got it working the way I expected. I was hoping this to be quick. It wasn't. But we'll have plenty of stuff to work on in the coming days.